Hi, this is Tony Northrup for Train Signal, and in this video lesson we're going to cover how to configure local security settings for Windows 8. This lesson is for the Microsoft Certification 70-687, Configuring Windows 8. This maps to Objective 4.3, and Objective 4.3 has 4 sub-objectives. Configure local security policy, which is this very antiquated kind of thing that controls all these different security settings on a computer. Configure user account control behavior. UAC is that annoying thing that pops up whenever you try to change a setting or run an app that requires administrative credentials. We'll talk about secure boot. There's not really anything to configure, but I'll show you what it is. And we'll also show you how to configure a smart screen filter. So we'll cover all the basics of these, and then I have a very cool scenario that we'll go through where we configure the settings to meet some real-world requirements. First up, I'm going to show you the local security policy tool. So here I am at the Windows 8 start screen, and to edit security policy, you need to start at your administrative tools. So I'm going to search the start screen for administrative, and then I'll switch over to the settings here and click administrative tools. So this feels very like Windows 3.1 to me, but this is actually a program group. This used to be on the start menu, but now it's here, and the app we want to run is local security policy. So I'll double click it. This opens up the local security policy console, and there are just like hundreds of settings in here for you to go through, but I want to show you some of the most important ones. You can see they're organized pretty intelligently, and you can pretty much find what you need. The first group is account policies here, and we have a couple of subgroups within account policies that defines the password requirements and what happens if somebody guesses a password too many times. So the password policy is about the most important thing you can configure on a computer. This controls how long your password has to be, how frequently you have to change it, and you can see it's set up for convenience rather than security. The minimum password length isn't defined. The minimum password age and maximum password age aren't defined, which means users never have to change their password. And how often do people change their password if you don't require it, right? Never. Because changing your password is a pain. You always forget it. There are a couple of reasons that you want to require people to change their password, even though it's an inconvenience. One is this kind of theoretical cryptography rule. Over some time, a password can be guessed through brute force techniques. So you can just, if you know somebody's username, you can just keep trying different passwords using an automated tool that might try 100 different passwords a second. At some point, it will get the password right, no matter how long the password is. So if you never change your password, at some point, if somebody leaves a hacking tool running, it will get your password. If you change it every now and then, it'll probably never guess the password though. So that's one reason to regularly change your password. Another is that if somebody happens to get your password, whether they're just looking over your shoulder while you type it, or if they successfully crack your password, well, you don't want them to have your account forever, right? They can just keep checking your email indefinitely. So you might be hacked and not even know it. But if you change your password, you'll be locking that person back out. So enterprise environments almost always require passwords to be changed every 30 days. Sometimes it's every 60 days. And you can enforce that by setting the maximum password age here. You can see it's set by default to 42 days. And force password history. If password history is not enforced, as it is here, then somebody can just change their password right back to what it was before. And people do this. That's the reason the setting exists, because people don't like to remember a bunch of different passwords. So you really want to set this number pretty high, otherwise you'll find people just cycling through the same 3 passwords or the same 6 passwords, and that invalidates both of the 2 reasons you want to change your password in the first place. Now, this is a really important setting. Passwords must meet complexity requirements. You pretty much want to enable this, because otherwise, you know what people's passwords are going to be. It's going to be the name of their dog, or it's going to be their birthday, or maybe it's just going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Whatever it is, it's not going to be good. So turn on complexity requirements, and as you can see from the explanation here, it requires some uppercase and some lowercase and some numbers and some special digits, and we all know it's a pain to remember that kind of password, but The reason you want to do this is that it prevents password dictionaries from working successfully. So there are two types of attacks against passwords. The first is called brute force, and it just starts out guessing the letter A, and then it guesses B, and then C. And it works its way up to AA, AB, AC, until it gets up to 10 digits and gets through all the numbers and characters. And there are just, I don't know, zillions of combinations for a decent length password if you use a brute force attack, and basically it will take forever. But there's a much more effective cracking technique, and that's to use a dictionary, because people aren't all that creative with their passwords. We use a few hundred, a few thousand passwords over and over again. You know, every dog name you can imagine, every combination of the 365 birthdays that we might have. So the password dictionary just has all those commonly used passwords in it, and a cracking tool just goes to those passwords and it'll find it, somebody's password, if it's common, in minutes. They're even conveniently sorted for the cracking tool with the most common passwords, things like 1, 2, 3, 4, first. So often you can get into a few accounts in seconds. So requiring complex passwords basically means that the password's probably not going to be in a dictionary, and the attacker would therefore have to use a brute force attack instead, which would take much longer. Store passwords using reversible encryption. By default, passwords are stored using non-reversible encryption. In cryptography, we have a couple of different techniques. We have encryption, and encryption is always reversible. You take something, you encrypt it, and then somebody with the right key can get the original text back. There's a second concept called hashing. Hashing takes your original content and morphs it into something that's usually shorter and looks like a random bunch of characters. But the way a hashing algorithm works is it will always return the same hash when you have the same original set of data. So the way passwords work is, if somebody's password is Sandy, that's my dog's name, it might generate a hash that is 77272. Well, Windows will store that hash in the password file. Now, whenever I go to type my password, Sandy, it repeats the hash on whatever I typed and then compares my hash to the hash that's stored. That way you can validate passwords without actually recording your password using anything reversible. So I can't, as an attacker, go in and simply find the right key to decrypt everybody's passwords. No, I need to try every password and hash every password and then compare the hashes. So the early versions of Windows used reversible encryption, and of course people just made tools that would let you get everybody's password by decrypting the passwords. And it was a terrible idea. And Microsoft figured this out and they started using non-reversible hashes. Some old apps still require using reversible encryption. You'll probably never see it, but if you do have that app, this is where you would go to enable it. Now, the account lockout policy is talking about people guessing passwords. Brute force attacks could take thousands and thousands of guesses, so you don't usually want people to guess thousands and thousands of times. So the account lockout locks out an account after a certain number of invalid logon attempts. 6 is a pretty common number. If somebody types the wrong password 6 times, the account is locked out, and they can't log in until an administrator with a separate account goes in and resets the account. So there's a downside to it. The legit user can't get in after somebody attacks their account. So you also open yourself up for a denial of service attack there, because somebody who simply didn't want anybody to get anything done could just go guessing passwords for everybody they knew until their accounts were locked out, and then those people wouldn't be able to log in. So that's a pain. You also have people who forget their passwords. After all, you're probably requiring them to change their password, and they're trying to remember it and they mistype it a few times, and bam, they're locked out, and now they can't get back to work until they call IT and they wait for the ticket to be processed and their account to be reset. So account lockout settings are a real pain. But at the same time, it's an important countermeasure for dictionary-based and brute force-based password cracking attempts. Now you can see when I set an account lockout here, it suggested a couple other settings that are back there. They're related. The duration, which by default is 30 minutes, and how long it takes for the lockout counter to be reset. Now the lockout counter is the count of invalid logon attempts. So you can see that the lockout threshold is 6 attempts and it resets after 30 minutes. That means that an attacker could try 6 times every 30 minutes. Or they could try 5 times every 30 minutes and leave that one valid logon, so the account never gets locked out and the user doesn't detect the ongoing attack. Let's move on to the local policies. These are pretty important. The audit policy defines which types of events can be audited. For example, in another lesson we covered object access auditing. If you want to be able to audit who touches particular files, you need to turn this on. Success auditing always means that somebody tried to access something and they had the proper authorization and they got it. Failure means they tried to access something and they weren't authorized to get it, so the system rejected their request. Some of the other things you can audit are logon events, which are just users logging on and logging off. Very similar account logon events. This exists at domain controllers and it registers domain users logging on with their domain accounts. Logon events refer to local accounts. Account management are things like creating and deleting user accounts. Policy changes are what we're doing here, changing the local computer policies. And then privilege use, process tracking, and system events are 3 very low-level types of auditing that occur when apps do different things and the system does low-level activities, but they're generally not directly the result of a user action, and looking at the audit information doesn't necessarily tell you what's going on anyway, so they're not terribly useful. So the next subgroup here is user rights assignment. And honestly, the defaults here work pretty well. This is the way that different groups get access to different system resources. So here's an important one, change the time zone. As we edit this, we can see that administrators and users both have access to change the time zone on the computer. And why wouldn't they? That's useful, right? But if for some reason you didn't want your users to be able to change the time zone, you could just remove that. Local service here just refers to the services running on the local computer, basically the system itself. So I won't go over every user rights assignment here, but you can see there's tons of useful things and the defaults are usually pretty good. So I'll look at this one here, take ownership of files or other objects. By default, when you create a file or any object on the system, you're the owner of it. And owners can do things like change the permissions of it. Now, administrators can be denied access to an object, but they have the ability to take ownership of it. So when they're denied access, they can actually go in and change permissions so that they make themselves the owner and therefore they can access it. And that's a pretty important right for somebody to have, because when you have that, well, you can access any file on the system. A user couldn't say fill up the drive with gigabyte after gigabyte of data and deny the administrators access to it. If that were the case, the administrator would never be able to clean up the disk space, and I guess he would have to throw the computer away or reformat the drive or something. But by granting administrators the right to take ownership of the file, well, you give them more ability to manage the system, but you also allow them to see any file on the computer. And that's pretty scary, because you might not want your IT guy to have access to every secret in your organization. Here's another one, shut down the system. This is pretty self-explanatory. Naturally, users are allowed to shut down their own computer, but for a server, you might not want a standard user to be able to administer it. So let's move on to security options. These are pretty important too. And again, I won't try to go over every one of these security options because there are a lot here, but I want you to see a few key ones. Block Microsoft accounts. Microsoft accounts are a new type of account introduced with Windows 8. In previous versions of Windows, everybody logged in with a local account, which means you didn't authenticate with a Microsoft service or anything. If you want it to remain that way, if you don't want users logging on with their Microsoft accounts, maybe you don't trust Microsoft to authenticate you, well, go into this local security setting and change it so that users can't add or log on with Microsoft accounts. We talked about auditing a little bit earlier. Here's an interesting one. Many organizations have regulatory requirements to audit stuff, like who accesses personnel records. Healthcare organizations, for example, have these HIPAA, the HIPAA regulations, that require them to audit everybody who accesses any healthcare customer's medical records. Makes sense, right? It's really important that nobody be able to access files without it ever being logged. Well, this type of information goes into the security log. And what happens if that security log fills up? What if the computer runs out of disk space? You wouldn't want people to be able to continue accessing files without the ability to audit it, right? No, you could be fined a lot of money for that. So for that sort of situation, you would enable this particular security setting, and it would cause the computer to shut down if for any reason it was unable to log security audits. Now, that might seem like a far-fetched scenario, but it's not. If you were a malicious attacker and you had the ability to just upload a file to the server that had the personnel records on it, you could just keep uploading files until it was all filled up and then access the records knowing that the security log could not possibly add another entry, and there'd be no trace of your actions. Here's another policy that's relevant for security. By default, users can install their own printer drivers. That sounds great, right? Because user goes into a meeting and they need to be able to print something at a partner's site, they can just connect to a network printer and print it off and hand it to the potential client. That's great, except that it requires their computer to download a new driver. And drivers are basically software. Drivers can do a whole bunch of really important things on the system, including potentially install malware. So by default, it's set up so that users can install a printer driver and your salesperson will just be able to print something at the client site, no problem. You can choose to enable this policy to disable installing these printer drivers. Imagine this scenario. The client is actually a clever competitor, something called a corporate spy, and they pretend to be a potential client. They get your salesperson in there and they ask the salesperson to print something important using their printer. Well, they've loaded that printer up with a malicious driver, and that malicious driver gets automatically installed when the salesperson goes to print something. That malware could, for example, install a keylogger. It could transfer all of his files to some corporate server. With this simple print job, all your corporate secrets could be disclosed to your worst competitor. So security is always a compromise between convenience and risk. And if you disable this policy and allow people to install their own print drivers, well, that's really convenient for them. They can get more work done. They might be able to make a sale. If you enable this policy and prevent users from installing print drivers, well, you've made your data a little safer. Whether or not that extra convenience is worth the security risk is something that every organization needs to decide on their own. So let's move on with some more security policy options here. Here you just see the Windows Firewall console, which we've covered in other videos. The Network List Manager policies define the particular properties for any given network depending on the state that Windows determines, unidentified, identified, or not. We've covered this in another lesson. Now, public key policies are something we really haven't talked about. Public key refers to public key cryptography, which is this complex system of private keys and public keys that almost all encryption and cryptography is based around. Everybody gets their certificate and their public and private keys are stored on that. And this complex public key infrastructure allows everything from authentication to digital signing and cryptography. And so it's terribly important. And for the most part, as a Windows 8 admin, you won't have to configure this. This is more of a server infrastructure type policy. Software restriction policies are kind of an outdated method for controlling which software will run and which won't run on a computer, but it's not commonly used. Nowadays, we pretty much use AppLocker here, and we've covered AppLocker in a separate lesson, so I won't go into detail here. IP security policies here. This is IPsec, and we've also covered this in a different lesson, so I won't repeat myself. And finally, the Advanced Audit Policy Configuration tool here provides access to the same types of auditing that you saw up here, except it goes into much more detail. So you can see you can turn on audit logon events here. Well, down here, you also have the account logon policy, and there are actually 4 separate audit policies. So you can turn them on up here, and then come down here to control it on a more granular level. I don't know why they put it in a separate node. It really should be grouped up here, but this just gives you more granular control over exactly what's audited after you turn on auditing. So now I'm going to show you how to configure user account control behavior, UAC. Now first let me demonstrate exactly what UAC is. I'll jump back to the start screen here and try to run an app with administrative credentials. Old character map here probably needs admin credentials, so I'll select it and then click Run as Administrator. This is user account control. It confirms that you want to do something. Now, it might seem silly. I just decided to run this app with administrative credentials, so why does Windows ask me, are you sure you want to do that? I wouldn't have done it, right? Well, the thing is that malware often does things on your computer without you intending to do it. It can run it in the background without you ever actually confirming it. So prior to Windows Vista, back when Windows XP was king, this happened all the time. Apps were making changes to the system and running things with administrative credentials, and the user had no intention of doing it and they didn't even know about it. So Windows Vista introduced user account control to try to put an end to this, and it's one of the reasons everybody hated Vista, because suddenly you went to even change the time zone on your computer and you get one of these prompts. So it felt like every time you were doing anything you had to then confirm it. Now, UAC prompts appear different depending on the type of account you have. I have an administrative account, so it simply prompts me yes or no. Now, if you log on with a standard user account, well, you can't elevate a standard user account to administrative credentials directly. You need to provide administrative privileges. So it will prompt you for a username and password of an administrative account. You have a lot of control over how UAC behaves. I'll just run this and you can see that character map now has administrative credentials. To configure UAC, you use local security policy. And the policy you're going to use is under local policies here and then security options. Down towards the bottom here, we'll see a whole set of policies related to user account control. Leave a little room for this here. So let's take a look at these different policies in order. The first is admin approval mode for the built-in administrative account. Now, the built-in administrator account, I'll show you quickly by opening up the computer management console. Selecting the users node here to view all users. Every computer has a built-in administrator account. It's been this way since the very first version of Windows, and we used to always log in with this. But of course, it was rather susceptible to hacking because you already know the username. So everybody, when they went to hack a computer, they just used the administrator username and just waited till they got the password right. Nowadays, the administrator account is always disabled by default. You can see this account is disabled, checkbox is selected here. So this particular policy is referring to that built-in administrator account and whether or not it uses the admin approval mode, which is what I just showed you, where you just have to click yes instead of typing a password. And so nobody logs in as that account, and you'll probably never have to worry about that particular policy. This policy allows UE access applications to prompt for elevation without using the secure desktop. Now, the secure desktop is the system that made the whole screen go gray. So I'll show it to you one more time by, once again, launching my favorite character map here. Now you can see the background is gray. It's showing my desktop. I can't interact with anything. Basically, it just hid everything on the desktop. And there's an important reason for this. Apps can't readily simulate this. So it makes it more difficult for a malicious app to trick you into clicking yes here, because they could put something else on the desktop that would dress this up, or write something around it that said just click yes, we don't care. Anyway, so it hides it. It just shows your desktop background. It means that malicious apps can't interfere with the desktop. So you can see that by default this is disabled, and You know, some people find the secure desktop annoying, and in the Windows Vista era where you were getting prompts all the time, I actually turned off the secure desktop because it was so annoying. But I find in Windows 7 and Windows 8, the prompts aren't that common that it's a problem, so I just leave the secure desktop on. It is safer after all. Now, we see a couple of different policies here for the behavior of the elevation prompt. This one is the controls the behavior of the elevation prompt for administrators in admin approval mode. And that is what I just demonstrated. We can choose exactly when it prompts. Now, the default here is prompt for consent for non-Windows binaries. That means that it won't prompt for consent for Windows binaries. So what we can do is, I have the administrative tools group open here. Now launch an administrative tool. Now, did you see the UAC prompt? I didn't, but UAC actually did elevate my privileges because the computer management console requires administrative credentials, but it didn't prompt me for it. The reason is that this shows prompt for consent for non-Windows binaries, that's selected, and computer management console is actually a Windows binary. Now, the character map is technically a Windows binary too, but for whatever reason, it hasn't been signed, so Windows 8 is treating it more like a third-party app. If I were to change this to prompt for consent, it would prompt me for everything, including Windows binaries like the computer management console. If prompt for credentials is selected, instead of just clicking yes, I would actually have to type my password, so it makes it a little bit more secure and a lot more annoying. Prompt for consent on the secure desktop and prompt for credentials on the secure desktop just requires the use of the secure desktop if it's not required by another policy. And elevate without prompting is the most friendly and convenient policy, but it's also the least secure. If you have elevate without prompting selected, you're turning off user account control. Any app just gets administrative credentials whenever it wants, whether it's malware or not. So you would only want to use that policy if you're pretty sure you're never going to be running any malware, which you can't be that sure because stuff gets on your computer through websites and Trojan horses, things you think are legitimate apps. So I don't recommend turning on elevate without prompting. So this policy controls the elevation prompt for standard users, not administrators, and by default it prompts them for credentials. Of course, you can't just prompt a standard user to confirm it because they don't have administrative credentials, so it can't automatically elevate. Everything requires the user to type an administrative username and password. So there's the difference between prompt for credentials and then prompting on the secure desktop. And finally, we can just automatically deny any elevation requests. So if a standard user without administrative credentials tries to run an app that requires admin credentials, it just won't run. UAC will just behave as if you denied the elevation request. This makes it very safe for the user. They can't possibly do anything that requires administrative credentials. It can also cause some apps to fail. So set it to that only in environments where you're sure you've tested all your apps and nothing requires administrative credentials. Our next UAC policy, detect application installations and prompt for elevation. This is pretty meaningless now. You have to understand a little bit about the history of UAC to understand the point of this policy, but back when we transitioned from Windows XP, which didn't have UAC, to Windows Vista, which did have UAC, well, we found out that there were a bunch of software developers creating their own custom setup programs, and these programs required administrative credentials. So people would try to install their app, and it would just fail because in Windows Vista, it wouldn't run with administrative credentials, and people didn't know they needed to like right-click it and then click Run as Administrator. So when you enable this policy, which it is by default, Windows will look out for things that look like a setup file. And if they are a setup file, well, it automatically prompts you to elevate it using UAC. How does it know if it's a setup file? It's probably called setup.exe or install, something like that. It's basically the file name and a few other metrics. But nowadays, everything is Windows Installer, so it's really not an issue with modern applications, but it might still come up with older applications. It's fine to leave it enabled. This policy only elevate executables that are signed and validated. This, if you were to enable this policy, Windows 8 would never elevate anything that wasn't signed and validated, even if it required administrative credentials. So basically, apps that weren't signed and validated would fail. So You might be able to turn this on, but you'd have to do some real thorough testing first to make sure that your users didn't require anything that wasn't signed and validated. Then, if you enabled it, it would indeed improve your security by reducing the risk that malware would be able to successfully elevate privileges. By default, UAC will only elevate applications that are installed in secure locations. So this is important to understand. When somebody downloads an app, the downloads folder isn't considered a secure location. The Windows folder is. So enabling this policy, which it is enabled by default, makes it more difficult for malware to eventually elevate privileges because the malware by default wouldn't be located in a secure location and thus wouldn't be allowed to elevate privileges using UAC. Admin approval mode is what I've been demonstrating, where you just have to click yes as opposed to having to type a whole password. By default, anybody who's a member of the administrators group uses this much more convenient admin approval mode. You can disable this if you want users to type their password. Another policy about using the secure desktop, and you can see it's enabled by default. Again, to understand this policy, we need to go back into history a little bit, but virtualize file and registry write failures to per user locations. So back in the Windows XP days, remember Windows XP didn't have UAC, app developers just stored their files wherever they wanted because every user had administrative credentials and could write to any part of the system. So app developers would just save files in the system folder and in the program files folder and places where you shouldn't be saving user files. So Windows Vista, to make these apps run, came up with this really complex file and registry virtualization system where it tricked the app into thinking it was actually updating the system registry, but instead it was updating a user-specific copy of it. It was kind of like the matrix for an old app. And the app thought it was running in Windows XP or something and it had system privileges, but it didn't actually. So this, you can just leave it enabled. It just helps older apps function properly, but honestly, we don't run many of these apps anymore, so if you wanted to improve your security, you could disable it and then test the apps that you do use to make sure that they work properly. And that is all the UAC policies. I will also show you how you can configure UAC without using policies. I'll jump to the Start menu here and search for User Account Control. Under the settings, there are a couple of policies here. I'll click Change User Account Control Settings. And you can see this user interface is a lot simpler than the policies that we were just digging through. It just has 4 different modes, basically. And by default, you're at this third mode where you notify when apps try to make changes to my computer, but don't notify you when you make changes to Windows settings. You basically saw the same setting described in different policies here. If you move it to this top setting, it will bug you every single time anything tries to make a setting, including Windows components. So up at the top here, more secure. Down here, things get less and less secure. Finally, down here at the bottom, UAC is completely disabled. So this is really convenient, but you shouldn't ever use that. UAC is a good thing and you don't want to turn it off. This second setting, one from the bottom here, has the same behavior here, except it just disables secure desktop. So it's a little less secure because secure desktop helps a little bit, but mostly it's a convenience thing turning it off. So I feel okay about this setting, but I wouldn't ever use this setting, which disables UAC. Now let's talk about Windows Smart Screen. I'll back up a little bit and talk about Internet Explorer 8, which is the browser that most people are using on Windows 7 and earlier versions of Windows. IE 8 as well as IE 9 have a feature called Smart Screen. And Smart Screen just checks out the website that users visit before they visit it. So you type in a new URL, trainsignal.com. Internet Explorer then checks with Microsoft and says, hey, do you know anything about trainsignal.com? Is this okay? And Microsoft maintains this list of websites that are okay and those that are potentially dangerous. And if for some reason trainsignal.com are dangerous, it would tell Smart Screen and Internet Explorer. And Smart Screen would warn the user before allowing them to visit it. So Smart Screen just basically helps users avoid, say, a phishing site, which might pretend to be a banking site to gather somebody's account information. Now, in Windows 8, they've extended Smart Screen down into the operating system itself, because Smart Screen's good. It helps protect you from malware and phishing sites, but it only works in Internet Explorer. So they've integrated it into the operating system. And the way it works is it will monitor new apps that you might run, because an app, an executable file, could potentially do dangerous things on your computer. So if you go to run something new and it's come from the internet, well, Windows 8 labels it when you download it, and before you run it, it'll say, whoa, I don't know about this app. Be careful. Now, it does it pretty intelligently. It doesn't warn you before every single app. Instead, it compares it to a list that Microsoft maintains of apps that other people run and trust. So if you download Adobe Reader, well, lots of people use that and trust it, and it won't warn you because it'll recognize it. If you download some new app and it's unsigned and nobody's ever seen it before, Smart Screen's probably going to pop up and say, this app might be okay. It might not. If you download an app that's known to be malware, Smart Screen can also pop up and say, look, I recognize this app and I don't think you want to be doing this. So let's look at how to configure Smart Screen. It's pretty easy. This is our Windows 8 start screen, so I will just search for Smart Screen from it and switch over to searching the settings. And here we can see change Smart Screen settings. This opens up the Action Center, which warns you about various security problems you might have with your computer. You can see a link over here, change Windows Smart Screen settings. And this gives you the three options that you have to configure Smart Screen. Pretty straightforward. The default here, get administrator approval before running an unrecognized app from the internet. That's what I just told you about. Now, the second option, warn before running an unrecognized app, but don't require administrative approval. The difference here is that this will require somebody to type in an administrator password, just like UAC. This is more like just confirming. Like you can just click, all right, I'm ready to go forward. You don't have to type a password. And this last option here just turns off Windows Smart Screen. So by default here, the most secure setting is selected. If your users are finding Smart Screen to be a pain, then you can turn it down a little bit where they don't have to type an administrative password. Or if it's just a real nuisance and you don't realize any security benefits from it, you could just turn it off. But I urge you to leave it on until it creates a problem. If you really are getting complaints, and I don't think people really do, then think about turning it off, but you accept some extra security risks. And in my experience, Smart Screen just isn't a problem, so you don't need to worry about it too much. So now I'm going to talk about Secure Boot. Secure Boot is maybe the coolest feature in Windows 8 that you'll never see. And in fact, most people won't ever appreciate it. But the security benefits that it provides are pretty amazing. Right now, there's this thing called rootkits and bootkits. And they're the ugliest form of malware that you can imagine. They run below the operating system. They start before Windows. And that makes them completely undetectable, or at least potentially undetectable by Windows. They can hide on your computer and no anti-malware can detect them. Here's another scary thing. They can do anything on your computer. They can capture every key that you type. They can record your screen constantly. They can turn on your webcam and record you physically. They can send it off to the internet. They can install malware. They could put terrible files on your computer or take all of your files and put them somewhere. They know every password you type. They know your social security number, and you can't ever detect it. Here's another thing. You could reinstall Windows and it would still be there. For firmware rootkits, you could even replace the hard drive, put a whole new hard drive in there, and it would still be present. These rootkits are a real pain, and they're basically impossible to get rid of. Well, they're potentially impossible to get rid of. Some of them, there are tools out there to detect and remove them, but many of them just not. You get them and you move on to a different computer. You could replace the motherboard and the hard drive and you'd be pretty safe, but that's most of the guts of the computer. Become trash with the right rootkit. And installing them is no harder than really any other malware. If something can get system privileges, if it manages to exploit a vulnerability in Windows or any other operating system, it can install it and it will be there forever. So these rootkits and bootkits are a nightmare. They're spread all over the place and you can't easily remove them. It's a massive problem with every operating system out there. So Microsoft, working with a group of other software and hardware organizations, has come up with this concept for Secure Boot. And what Secure Boot does is it just checks your bootloader. It actually has a really easy job. Secure Boot runs in your firmware, which we used to call BIOS, but it requires UEFI firmware. That's a new type of technology that replaces BIOS. It's basically the software that starts before your operating system starts. It's what appears the very first moment you turn on your computer, and it has some black and white screen and blocky text. That's probably your BIOS or your firmware. On computers equipped with UEFI firmware, and that includes all Windows 8 certified computers, they have a Secure Boot feature. And the Secure Boot feature just checks out the bootloader that it runs, and it makes sure that it's a trusted piece of software. So if you buy a new Windows 8 computer now, and it's Windows 8 certified, it'll have UEFI firmware, a trusted platform module, a TPM chip, that's another requirement for Secure Boot, and it will be configured to trust any software signed by Microsoft. So naturally, the Windows 8 bootloader is signed. But you know what software isn't signed and trusted? Rootkits and bootkits. If a rootkit replaces the Windows bootloader, Secure Boot will check the bootloader before it runs it and say, well, this isn't signed, it's not legit, I'm not going to run it. And the user will just get an error message saying it can't install Windows. And at that point, they could probably reinstall Windows or repair it or something. But the important thing is they won't be running that rootkit, at least without knowing about it. Now, Secure Boot's pretty nice. You can go in and you can install your own software, or even if you make a custom build of Linux, you can make Secure Boot trust anything. One of the requirements Microsoft has for Windows 8 certification is that you can either completely disable Secure Boot, or you can make it trust any arbitrary bootloader that you want. Malware can't do that. Malware can't go into the firmware and change it. You have to physically, with a keyboard, go in there and do it yourself. There's no way to automate the process, basically eliminating the risk that a rootkit could change the Secure Boot configuration on you. Now, the rest of this diagram basically just shows the rest of the boot process and how Windows 8 protects it. And it's not part of Secure Boot. Secure Boot is just this part where the computer's firmware starts up the Windows bootloader. After that, you move into other security technologies. Trusted Boot is new in Windows 8. And Trusted Boot checks the kernel to make sure that it hasn't been modified, make sure that it's signed and intact. And then the kernel checks the integrity of all the boot drivers to make sure that they're signed and intact. And it also checks all the system files. Now, there's another technology that's new in Windows 8, and that's ELAM, E-L-A-M, Early Launch Anti-Malware. And by default, this is Windows Defender, though you can replace it with your own anti-malware app. So by default, Windows Defender and its ELAM plugin will just check every third-party driver you have here. Now, that's not a Microsoft driver. This is a third-party driver for, your webcam or whatever hardware you might have equipped. Those can get infected with malware too. And if they do, it's called a driver rootkit. Well, it can do all the same bad things that rootkits do. So ELAM protects you here. Trusted Boot protects you in the beginning part of the boot process between the bootloader and actual logon. And then after your third-party drivers load, well, this is when your full anti-malware starts. So in Windows 7, you only had this protection down here once the full anti-malware started up. In Windows 8, you are protected right from the moment you press the power button on your computer all the way through. Makes it basically impossible for rootkits and bootkits to be installed. Now, maybe they'll come up with some exploit in the future, but I don't know of anything yet. As far as I know, Windows 8 certified computers in their default configuration are impenetrable to malware, and that's a huge relief. So I want to review a couple of points about Secure Boot because I want you to remember them for the exam. First, Secure Boot will only run a trusted bootloader by default. It's required that all Windows 8 certified PCs allow Secure Boot to be disabled or to allow third-party bootloaders to be installed. I'll also point out that Microsoft has a service where they will sign and trust software made by other vendors, so long as it is secure. And several different Linux vendors have gotten their bootloaders signed. What this means is that you can run several different builds of Linux with no additional configuration to secure boot. So it doesn't mean that you lose the ability to run non-Microsoft software. It just means you basically lose the ability to run bootkits unless you really want to, and you go in and either trust the bootkit specifically or disable secure boot. So they're not taking anything away, they're just giving you more. Secure boot requires UEFI and a TPM. Put this in your head because you're going to need this for the exam. UEFI is the BIOS replacement, and TPM, the Trusted Platform Module, is this little tamper-proof chip that's embedded somewhere on your motherboard. And when I say tamper-proof, I mean you can't go in and hook up some wires to it and read the contents of the memory. If you were to try to break into it, it would completely break. It's physically structured in a way where if you try to tamper with it, it will just demolish itself. The TPM chip does a couple of things. It stores certificates, like the certificate that you would use to decrypt your BitLocker protected drive. The TPM chip also stores the digital signature of your trusted bootloader, so it knows which bootloaders to run and which not to run. Some older PCs have UEFI and lots of them have TPM. All Windows 8 certified PCs have both these things, but I found that all my computers designed for Windows 7 don't support secure boot. So if you want to take advantage of this, you might be buying a new PC. So here's that real world scenario I told you about at the beginning of the lesson. We just got a list of security settings from IT that we need to enforce, and we need to make sure that this policy is applied to our Windows 8 computer. We need to require some 8-character complex passwords. We need to make sure the users change their passwords every 30 days, and we need to lock them out if they type the wrong password 6 times. We need to audit logon failures. We need to disable UAC prompts for admins. It doesn't make it more secure, it makes it more convenient. And we need to turn off Windows Smart Screen. Again, some of these choices are made to make things more secure, others to make things more convenient for users. So let's get started with that scenario. We're going to need the local security policy tool. So I will open up the administrative tools group and then launch local security policy. If you recall, passwords are under account policies here, password policy. We need an 8-character minimum password length, so I'll open this and set it to 8. And we need to enforce complex passwords, so I will enable the password must meet complexity requirements policy. Now, they also require that we have users change passwords every 30 days. So I'm going to change the maximum password age to 30. Now, they didn't explicitly say it, but we should also set a minimum password age and enforce a password history. So let's say you do not keep a password history and you don't set a minimum password age. Well, you'd force users to change their password, but they could just immediately change it back. And that would defeat the whole purpose, right? So the minimum password age means that the user can't change their password again for a certain number of days. That prevents them from just changing it right back. So usually 1 day here is enough to stop users from doing that. And then enforced password history just prevents them from swapping between 2 or 3 passwords. And I think it's best to force users to come up with a brand new password every time. So I like to make this some big number. You don't want to make it a massive number because Windows still has to store this in a list. But 16 is good enough that I think nobody's going to remember it. So these were not explicitly on the list of requirements, but we kind of infer based on our knowledge of how Windows works that the boss will want these things as well. All right, we also need to configure the password policy to lock accounts after 6 attempts. And you can see this is already a set. This is the account lockout threshold properties. Now, again, the policy didn't say what the account lockout duration should be or when it should reset. I think 30 minutes are good for both of those, but in a real world scenario, you need to think about your organization's specific security needs, and if you're not sure, go and ask your boss. Now, the next requirement from IT is to audit logon failures. Now, as you might recall, that's located under local policies and then audit policies. Now, they didn't say if they're talking about local accounts or domain accounts, but I think it's safe to say that we should do both. So here's the audit logon events properties, and I'm just going to turn on failure. I don't need success because they just asked for failures. And while I'm at it, this would only take effect on a domain controller, but it doesn't hurt. I'll turn on failure auditing for account logon events as well. Now, the next requirement was to disable user account control prompts for administrators. And that is a security option. So I'll select security options and then scroll down here to user account control. Now, it's tempting to run that policy, but this only applies to the built-in administrator account. The policy we want to edit is behavior of the elevation prompt for administrators in admin approval mode. And we want to disable it, which none of these say disable, but which actually want is to elevate without prompting. That just doesn't bother the user. UAC is still doing its thing. It's still managing 2 separate tokens for the user, running everything with standard user privileges unless it specifically requires administrator privileges, because you don't really disable UAC, you just disable the prompts. So we're elevating without prompting. And finally, one last policy, it was to turn off Windows Smart Screen. And you don't do that using local security policy for some reason. Instead, I'll search the start screen and then switch over to searching the settings and pick change smart screen settings. Now I'll change the Windows Smart Screen settings over here and select don't do anything, turn off Windows Smart Screen. So as soon as I turned that off, it immediately started to bug me. And we don't want users to constantly be looking at this thing telling them to turn Windows Smart Screen back on. So as long as we're in the Action Center here, I'm going to click Turn Off Messages about Windows Smart Screen. And now it won't bother me anymore. This is Tony Northrup for TrainSignal, and I hope you found the lesson both educational and enjoyable. And I'll see you next time.